Well, first I must say thank you all. This is a standing audience, which doesn't happen very often. But I thought of this topic because maybe I'll have people raise their hand. How many people work or are affiliated with infrared in the 101 corridor? Yeah. Okay, so I'd say about 50%. The other thing that I think is little known is that we are a high-tech community and that the 101 corridor, the underpinning of that is infrared. So though it is not heralded, it is probably the reason why we have such an incredible technology community. I travel around the world as the Director of Corporate Business Development at UCSB. And I come back and I think, what a diverse community we have. And it would not be the case if it wasn't for infrared. So our great good fortune is to have Kevin Riley here. I met Kevin probably within a year of him taking on Teledyne Scientific and Imaging, and I was just impressed with how far-reaching his thoughts were and how much he wanted to collaborate with universities. The one bragging point I will say is, out of the whole United States, UCSB is number 6 in terms of industry collaboration per faculty. So out of the UCs, we are by far and away the leader in terms of industry collaboration. And we've had a very long and kind of solid history with the infrared community.
Thank you, Leslie. And it's great seeing so many former colleagues and close friends here tonight. And our story about the Santa Barbara infrared development extends back over 65 years to just about the end of World War II. Our story has a lot to do about the sunshine here in Santa Barbara. It's a storyline filled with entrepreneurs, many of which are with us tonight, mavericks and dreamers that have made the impossible possible. It's indeed a tale of 2 universities, and Leslie's mentioned both of them, Syracuse University as well as UCSB, and the collaborations that have existed between those universities and the community, the industrial base here. And it's got a little bit of Texas in the story and a dash of the frozen north in the story. And it's a family tree of 3 generations with many branches to it. Before I begin, though, just to make sure we're all on the same wavelength, I've shown here the electromagnetic spectrum, the visible region between 0.4 and 0.7 microns, shown in the middle of the slide. And then the infrared region, which we'll talk about tonight, it's extending from about 1 micron in wavelength to about 10 microns in wavelength. Just to build on the infrared 101 theme, all thermal objects at any given temperature emit radiation. The sun at 6,000 degrees Kelvin emits in the visible, peaking in the yellow region, the sun we see. If we go to human bodies at about a little bit over 300 degrees Kelvin, you see that the peak of the radiation is in the 10 micron region of the spectrum. And that's one of the reasons that people over the years have been in search of detectors that are very sensitive in the infrared to have night vision devices that detect humans that can see when the sun isn't shining. If you're looking for rocket engines, at a hotter temperature in terms of thermal emission, you shift to shorter wavelengths. And you look in specific regions of the atmosphere where there are windows that don't absorb the infrared. And so 2 regions of high interest are the 3 to 5 micron region and the 8 to 12 micron region, where the atmosphere is transparent to the infrared. So human beings emit radiation at 10 microns. The atmosphere gives us the opportunity to see that radiation if we have detectors sensitive enough to see it, because the atmosphere transmits that radiation. So what is the current state? What exists here today? And I'm looking at about a 100-mile corridor from Malibu to Santa Ynez. It is the center of infrared research, development, and production. It is the industry here is coincident with the entire development of the infrared technology, about 65 years in duration, spanning the development of all the key IR technologies. RVS, FLIR, Lockheed Martin, Santa Barbara Focal Plane, Teledyne Imaging Systems, Hughes, the former Hughes Research Labs, HRL, Autoliv, Seek Thermal, and SBIR, just to name the major players in the community. My estimate is that they own about a 50% market share of a global economy and a global addressable market that is in excess, depending on how you define that addressable market, in excess of $2 billion. So we have about $1 billion of revenue generation here in the corridor out of these companies. In addition to that, we have the market leader in the military systems, RVS, the former Santa Barbara Research Center. We have the leader in commercial, FLIR Systems, the former Indigo Systems. We have the leader in automotive with Autoliv, and we have the leader in astronomy with Teledyne Imaging Sensors, the former Science Center down in Camarillo. In addition, these, 7 organizations are the strategic operations of corporations with a market capitalization of over $200 billion. The work that is done in these organizations enable and leverage billions of dollars of product at the corporation operations. So these organizations are not only important to our customers, they're also essential to the corporations that these organizations are embedded in. So that is just a sense of what exists here today. And out of that $1 billion, it should be stated, it is individuals that are like the individuals in this room. Over the 65 years, the engineering and the technical support, the people that have come to the area, as Leslie indicated, and have devoted their careers to this industry have made a difference. So there's been a tremendous development of the local workforce that serves these companies.
I just have 3 charts, talk a little bit about the industry to follow up what Kevin has talked about, but more in line with the economics that the technology has brought us over the last decades. If you put on the progression of basically the cost of a generic infrared camera as a function of time, it looks like a nice straight line on a log versus linear time plot here, and you can just see it, moving down, looking like Moore's Law or something. But if you really analyze what's happened here, it's all about disruptions. It's all about some new technology or some new approach to the business that's caused this industry to now change from being primarily the domain of the military, as it was about the end of the Vietnam War here in the early 70s until today. And early on, we saw $250,000 cameras being delivered to the Department of Defense. These were scanned cameras. They were cryogenically cooled, as Kevin talked about, and only the military and maybe a few industrial users could actually afford such a thing to see infrared light. Along the way, there was a business opportunity that came about with the realization that you could build the underlying substrate to these infrared detectors, which are 2-dimensional arrays, very, very similar to a visible, except for you have to put these exotic semiconductors like mercad telluride or indium timonide on top of them and connect them through something called an indium bump. But at that time, there was a realization that you could buy the underlying signal processing silicon from a foundry, and we decided to start a company here called Amber Engineering, and realized that most department heads had a capital budget in their discretion that was about $50,000. In fact, it was $50,000. If we came in at $49.95, we didn't have to wait for a capital cycle, so we priced a camera at $50,000, And lo and behold, it worked, and there were a lot of government laboratories and industrial applications that kind of came out of the woodwork that would buy some of these cameras. We had extremely high volumes now.
Well, before I begin, I'd like to thank Leslie for picking this topic and reaching out to the business community and selecting the speakers this evening. As Bill, described, I mean, this is a significant time in this marketplace as we transition from sort of a B2G or government business and B2B to B2 consumer. So FLIR is a very large company. We have 5 business units, and we have everything from a very high-end military business in which we sell products that have price points over $1 million, and we have consumer products today and component products that are sold for in the hundreds of dollars. But across that spectrum of price points and markets, we have the strategy of what we call controlling the corners. So we want to be strong across that by leveraging certain areas of technology. Bill was the innovator that sort of brought the foundry process to the readouts, or these devices that he described, and that was a big innovation in the industry. And we continue to have an excellent internal capability to drive innovation at the chip level. But it doesn't matter if it's a $50 product or a $1 million product, you need innovation at the chip level, and we continue to push on that or pull on that lever. So if you look at the price points, as I said, in the upper corner, you could be at $1 million sort of targeting pod with laser designation and all sorts of payloads in this highly stabilized product. And then at the low end, and I have some samples here.
Okay, so again, I'm Stuart Clapper. I think you heard my name a few times tonight. I'll tell you a little bit about our company. Our company is a safety company. So if we don't do anything unless it's safety related. We're the largest supplier of airbags in the world. We're the largest supplier of seatbelt restraints. And you can see a car has a lot of airbags in it, all over. It's not just the airbag coming from the steering wheel. It's all throughout your vehicle. We are also the largest supplier of infrared to cars. We also supply visible cameras and radars and everything else. And this is all in an attempt to someday make the car a very safe vehicle for us all to drive. You might ask the question, well, why are we putting this in the cars? This is, I can drive at night. I don't need this. But if you look at the fatalities that occur on a yearly basis, it's around 4,000 people here in the U.S. Worldwide, it's probably over 100,000 people are killed every year. But look at that second statistic, deer vehicle accidents. Here in the U.S. alone, there's about 1.1 million deer vehicle accidents every year, and that represents about $3.5 billion of property loss. So if you've ever hit a deer or any other kind of animal, you'll know that it's a terrible event, and you could lose your life in the event. And of course, when you drive at night, 69% of all fatalities occur at night. And there's a greater than four times greater chance that you'll have an accident at night with a pedestrian or an animal, and even though only 25% of our driving occurs at night. And if you hit a pedestrian, think about it. Sometimes we feel like our headlights are good enough and we know how to drive and our eyesight is good enough. But if you hit a pedestrian, you're going to end up in court for about 2 years trying to figure out how to save your life for being sued by hitting this pedestrian. And it could be a very emotional thing, not only for the pedestrian, but for you as a driver. So the system we sell is quite complex. You might think it's simple, but it isn't. Making the infrared camera, as difficult as that is not the hardest part of this. And I hope you can see this one, probably won't, is what we call spotlight technology and spotlight function. And as you're driving down the road, this happened to scene, unfortunately, you can't see it, is driving through Santa Barbara right by UCSB. And as you drive down the road, instead of seeing an infrared image, we actually put a spotlight on the pedestrians that are on the road. So it doesn't matter if they're on the left or the right. And as you know, a lot of people walk on the road by UCSB every night, and yeah. And so the spotlight technology actually puts a very nice beam of spotlight on the person that's out there. And we use the infrared to detect that person on the road, and the spotlight is directed, and we actually have 2 on each vehicle. Spotlight is directed onto the pedestrian and lights them up. And so just looking out the windshield, you drive like you normally do looking out the windshield, except you have a spotlight that you can see.